Okay, now for some word problems. So this is number 20 from worksheet 5. All right, you're catering lunch. It gives you 3 meal options with prices. It also says that the number of beef entrees is 6 greater than the number of chicken entrees. And then finally, the bill for 45 dinners is $534.75. So there's enough information here to write 3 equations. I have 3 unknowns: chicken, beef, and veggies. Yeah. And I have enough information to write 3 equations. So the first thing that I'm noticing is that there's 45 total dinners, okay? You want to make sure that with these problems, guys, when you have prices, all of the prices should go into one equation. So with the 45 dinners, that's just the total amount, meaning however many chicken entrees plus however many beef plus however many veggie entrees is going to add up to 45. So that's my first equation. The next equation, I would do all the prices. So that's going to be $10.95 for chicken, which is X, $12.95 for beef, which is Y, and $8.95 for veggie, which is Z. And that's going to equal the total, which is $534.75. Last but not least, this last bit of information, this number of beef entrees is 6 greater than the number of chicken entrees. That is always something that throws me off. You really have to think about it. So for example, so beef entrees is 6 greater than chicken entrees. So if there's 10 chicken entrees, that would mean that there's 16 beef entrees. So what that means is that the number of beef entrees, which is Y, is going to be equal to however many chicken entrees there are plus 6 more. Okay, so sometimes I end up writing that one backwards, and it's kind of hard to think about. So I would really just kind of use your brain to be like, okay, wait, which one's going to have more? How am I going to write this equation based on that? Okay, another clue is the word is. So beef entrees is means beef entrees equals. So Y equals. That's another way to think about it. I have 3 equations and 3 unknowns, which means I'm able to solve a system. This says use your graphing calculator, so I would probably use inverses. I suppose you could use polysymults to double check, but of course we want you guys to show the work from this unit. So the first part of the coefficient matrix is this first equation, 1, 1, 1. Dean must love math, guys. He's so excited right now. He's like yelling in excitement. I'm excited too. I love word problems. Yeah. Let's get the variables on the same side for this third equation. So that would be negative x plus y equals 6. So that's negative 1, 1. There's no z, so we put a 0. Yes. So to solve, we want to take the inverse of that and then multiply it by the solution matrix. So I'm going to, yeah. Wow. This kid is pumped. I hope you guys are too. My husband says they're not pumped, whatever. I'm just going to type this all on my calculator, kind of as a shortcut. So let's go to the calc. I actually just did this problem wrong, so I'm redoing it. So this is a 3 by 3. It's a 1, 1, 1. Yep. 10.95. 12.95. So when I did this wrong, I just kind of had a brain moment. Instead of x plus 6 in that last equation, I don't know why I said x plus 10. So it threw everything off. And then I realized my mistake when I didn't get whole number answers, because it wouldn't make sense to get like 4 1/3 veggie entrees. Okay, so I'm going to take the inverse. That's important. Don't forget to do raised to the negative first with that coefficient matrix, and then multiply by your solution matrix, which is a 3 by 1, and it's 45, 534, 75, and it's not 10, it's 6. And there we go, I get whole numbers this time, 18, 24, and 3. Okay, the question's actually asking how many veggie entrees, so the answer is 3 veggie entrees. Okay, another graphing calc problem. I'm not going to show the solving. I'm just going to show the setup for this because there's going to be 4 equations because we have a quadrilateral. Think about a quadrilateral, guys. There's 4 sides, A, B, C, D. Ooh, and there's clues. Angle B is, so I'm going to say B, okay, buddy. B is 10 degrees larger than twice angle C. So 2C plus 10. Angle A is, the word is equals. What's wrong? Let's give you a pacifier so you can stop talking for a minute. A equals 20 degrees less than 3 times angle C. So 3C and then 20 less than that, so minus 20. Opposite angles are supplementary. You can choose to either do B plus D or A plus C. It doesn't matter which, so I'm just going to do B plus D equals 180. Now I also could do, my next equation could be A plus C equals 180, or I could use the fact that all of the angles add to 360. So that's what I'm going to do. A plus B plus C plus D equals 360. Gorgeous. Get everything on the same side, like variable-wise. So B minus 2C equals 10. A minus 3C equals negative 20. The last 2 are good. So then in my calculator, here's what I would do. For the first equation, there's no A, there's a B. Negative 2 is the coefficient with C, and there's no D. Second equation, 1, there's no B. Negative 3, no D. Next one, there's no A, there's a B, no C, there's a D. And the last one's 1, 1, 1, 1. Don't forget in your calculator to raise that to the negative first and then multiply by the solution matrix, which is going to be 10, negative 20, 180, and 360. All right, and just timing-wise, I'm not going to put that in the calculator, but that is the setup, and this is what you would put in the calculator. Last but not least, I just want to do a quick graphing problem. You're going to really go in depth on how to graph a circle in the next unit, but hopefully you were taught that the quick and easy way to do this is find the center. So this center is going to be 0, 2, and the radius of the circle is going to be the square root of 9, which is 3. Okay, so 0, 2 is my center, which is right here, and then radius is 3. So count up 3, down 3, right 3, left 3, and that's going to give me a circle. And this is going to be a dashed circle. Okay. All right, I'm going to feed you in just a second. This is going to be a dashed circle because it is not inclusive. In other words, there's no underline on the inequality symbol. Okay, I know. The next equation is a line. Okay, so 2x minus 2. My y-intercept is negative 2, and my slope is 2. I like to graph first, and then I'm going to go back and figure out which way we're shading. Okay, so let's see, greater than. There's no underline, so again, this is going to be dashed. Okay, so here's the deal. We're looking for where the shading's going to overlap. For a line, we could do a test value, or y is greater than means I'm going to shade above the line. And for the circle, sorry, buddy, greater than means outside of the circle. Again, I could do a test value. So like if I picked a test value for the circle, I would always pick 0, 0 if I could. And if I plug in 0, 0, I get 0. 0 minus 2 is negative 2 squared is 4. So 0 plus 4 is greater than 9. That's 4 is greater than 9, which is false, which means I would not shade towards 0, 0. Which is why I'm shading outside the circle. Okay, so where does this overlap? It overlaps above the line but outside the circle. So that's over here. Okay, and the baby is, no, I'm good. The baby is telling me it's time to go, and this is the last problem I'm doing anyway. So that is the solution, and I hope that's helpful. Good luck, you guys.